Hello everyone, myself Ved, and today we are going to discuss another series of questions. So here we have some information. It's talking about the Gibbs free energy relationship with enthalpy and entropy with absolute temperature. So as you can see, delta G is equal to delta H minus T delta S, and here we have another equation in which delta G is equal to minus 2.303 RT log K to the base 10 K equilibrium. And here we have an expression how to write down the K equilibrium, and we know that this is the product and this one is the reactant. So as you can see here, so if you are going to write down the K equilibrium, so it should be K equilibrium will always be concentration of product divided by reactant, and power would be stoichiometric coefficient. What is stoichiometric coefficient? Stoichiometric coefficient means these numbers 2, 3, 4, 5. So product is C and D, and you can see stoichiometry is 4 and 5. So C to the power 4, D to the power 5, and here A to the power 2 and B to the power 3. Okay. So now move to the next question. So given that standard free energy change for the reaction glucose plus PI gives glucose 6-phosphate, and which is 13.8, sorry. So glucose plus gives glucose 6-phosphate and its energy is 13.8 kilojoule per mole. And the next equation is ATP gives ADP plus PI, which value is minus 30.5 kilojoule, and we have to figure out for this reaction. This net equation. So as you can see, if you look at this net equation, my glucose 6-phosphate in the product side, and yes, here it is in the product side, and ADP also in the product, yes, ADP also in the product. You have to add both of the equation, and once you are going to add, then we can get the final equation which is given in the question. Clear? So you know that if anything is same in the reactant and product side, so we can cancel out them. So this is going to be cancelled here, and now if you are going to add here, so we can say glucose plus ATP gives glucose 6-phosphate plus ADP. Clear? And now you can match your final equation. So if you are going to add, then we can add these energy as well. Okay, so 13.8 plus, and the value is here minus 30.5. so what it should be? The sign should be definitely minus, okay, because this is bigger one and they have minus sign. So this is minus, and if you are going to subtract, so we can get this minus 16.7, and this is only the value which is in the minus. So I think it should be C, and you can cross check. Okay. Now the next is which option is true about the following reaction. ATP gives ADP plus PI. Spontaneous, non-spontaneous, equilibrium, and none. So it's quite simple one. Whenever delta G value is less than 0 or negative, then we can say reaction is spontaneous. And whenever delta G greater than 0 or positive, then we can say non-spontaneous. And whenever delta G equal to 0, then we can say equilibrium. So for this equation, the delta G value is given, which is, you can see, minus 30. So minus sign indicates the reaction is spontaneous. So we can say this should be spontaneous. Okay. Now the next one is, what should be the K equilibrium expression for the following equation? So in equilibrium, we don't have to consider anything in the solid and liquid phase. We can consider only the gaseous and aqueous phase. So we all knew The K equilibrium is concentration of product divided by reactant, and here the power would be stoichiometric coefficient. So this is my product, the right hand side, and left is my reactant. So reactant must be in the bottom, and you can see this H2O in the liquid, so do not consider this. So if any of the option have H2O, then that should be wrong. So here we have H2O, so this is wrong. Now only K2CO3 divided by, this is CO2, wrong. I don't know why this is CO2, because first product, then we can put reactant in the bottom. So K2CO3 divided by KOH and CO2, KOH and CO2, KOH have 2 stoichiometry, so power should be 2. So option number A is right. So for the change that occurs when vaporization takes place, what is vaporization first of all? Vaporization means liquid to gas, okay? So liquid to gas. So here we have two things, delta H and delta S. So liquid molecules are very close to each other. They have good intermolecular force between them, and gaseous molecule R is a bit far from each other, okay, like that. So if you are moving liquid to gas, it means there is a bond breaking. This is a bond breaking. And if you are going to reverse gas to liquid, this is bond forming. So liquid to gas is a bond breaking, and bond breaking is an endothermic process, and endothermic means delta H sign should be positive, okay? So enthalpy should be here positive because reaction is endothermic. Now what is entropy? Entropy is a randomness of the system. Higher the randomness or disorderness, greater the entropy. So if you are going to arrange the entropy order, then gaseous molecule have higher randomness than liquid and then solid. Why solid have lowest? Because they are very close to each other, so randomness is very less. Gaseous are randomly in nature, so they have highest entropy. So if you are moving liquid to gas, it means randomness increases or disorderness increases, so entropy is positive. So both should be positive, I think. Yeah, option A. Now the next one is, which statement is true for the following reaction? So glucose, Pi gives glucose 6-phosphate, and here we have entropy positive. So first define entropy here. You know, before this question, I decided the entropy nature on the behalf of their phase, like gas, solid or liquid. If the phase is not given, only the moles are given, then higher the number of moles, greater the randomness and higher the entropy. The left hand side we have 2 mole. The left hand side we have 2 mole. The right hand side we have just 1 mole. So my mole decreases. So mole decreases means entropy decreases. So entropy decreases means it should be negative. So entropy is positive, that's wrong. Glucose plus Pi gives glucose 6-phosphate, and this is spontaneous. It means the delta G must be negative. So let me check the delta G value first of all for this reaction. Glucose 6-phosphate. Yeah, this value is positive here. You can see 13.8. So this value is positive, that means non-spontaneous. So this is positive in this equation. Delta G is here positive, which means non-spontaneous. So this is wrong. Entropy negative. Yes, we have negative entropy because mole is going to decrease, and reaction is non-spontaneous. Yes, delta G is positive, so reaction is Oh, what is delta G? Positive. Yes, positive means yes, non-spontaneous, correct. And the third one is entropy positive, which is wrong. So option C is absolutely correct because reaction is delta G is negative. Negative means spontaneous. Oh wait, something is wrong. Non-spontaneous means delta G positive. Okay. So here we have something wrong about the combination, I think. Here it should be another option, means this is entropy positive. If we have entropy negative here, then oh wait. Yeah, I think that's correct answer. Wait. The delta G is positive value. So positive means non-spontaneous. Yes, that's right. So this is positive. So reaction is non-spontaneous and entropy negative. So option C is absolutely right. Clear? And if reaction is saying is spontaneous, it means delta G should be negative. But the given question is delta G is my positive, which is given in the data. Okay. So this reaction, this question is absolutely correct. So answer C for question 5. It makes sense. Again listen me. For this reaction, my mole decreases. So mole decreases means entropy decreases. So entropy is negative. Delta S is going to be negative. And delta G if positive, then reaction is non-spontaneous. And if delta G is negative, then reaction is spontaneous. Clear? So for this question, the delta G is given, which is positive. So positive means reaction is non-spontaneous. So option C is absolutely correct. So this is all about this series of questions. So thank you so much for watching this.